Okay, so let's look at a couple examples. It's going to ask us to find the arc length of the curve on an indicated interval. So let's look at the curve y equals 3/2 x to the 2/3 plus 4. If you want, you could sketch a graph of that. And we're going to look on the interval from 1 to 27. Now, for my formula, what I need is y prime. So that's our first step, is we're going to look at what is y prime. So take our derivative, we have 3/2 times 2/3 times x to the 1 less power. The derivative of 4 is 0. So I get that y prime is x to the negative 1/3. In our formula, we need 1 plus y prime squared. So I'm going to do that down here. If I square this, I get x to the negative 2/3. Now I'm going to go plug it into my formula. So the arc length on the interval from 1 to 27 of the square root of 1 plus my derivative squared dx. Now, most of the time, I'd say 90% of the time, we're not going to be able to integrate these by hand. So, for your homework, and for these on the board, I want you to integrate them using your calculator. Okay. So just a reminder, that's Math 9. Okay. Now, if you don't have one of the calculators that brings up the integral and it looks like a square root, you have to remember that your calculator puts a parentheses here to start what's under the radical. You have to close it before you go to the next part. So, whoops, if we do this on our calculator, we get that the answer is approximately 28.794. Just a reminder that in calculus, if you're using a decimal, that it always must be at least 3 decimal places. You don't have to round, it just needs to be 3. So again, took the derivative, we squared it, and then we plugged it into our formula. Let's try another one. Let's suppose y equals the ln of x, and we want to check it on the interval from 1 to 5. So again, the first step is to take the derivative. The derivative of natural log of x is 1 over x. And then I'm going to square that. That's 1 over x squared. Now we'll plug it into our formula. Arc length on the interval from 1 to 5 of the square root of 1 plus my derivative squared dx. And again, we'll plug that into our calculator, and you will get approximately 12.755 if you truncate it, or if you like to round, it would be 12.756. The last example I want to look at is going to be in terms of x and not y. So let's suppose we're given x equals the square root of 30, that's completely the wrong question, that was a homework question. X equals y minus 1 to the 3/2. And we're looking on the interval from 1 to 5, but now we're looking at the y values because my function is in terms of y. Still the same first step. We need to take the derivative. The derivative is 3 halves times y minus 1 to the 1 less power times the derivative of what's inside, which is 1. So doing arc length is another good review of all of your derivatives, whether it's chain rule or product rule or quotient rule, ln e to the x. Okay. So now I'm going to square my derivative. So I get 9 over 4 times y minus 1. So when I square root, it becomes that. Now we will go to our formula. So now my arc length, in terms of the y, from 1 to 5, the square root of 1 plus my derivative squared, dy. Now this one, technically, we could distribute, do a u sub and solve it by hand, but again, almost all the time you're going to be asked to evaluate these with the calculator, or it'll be a multiple choice question asking you something about, is this the right setup? If you do this on your calculator, you will get approximately 9.073. Now something else. Just because this integral is in terms of y here, when you go to Math 9, you can still use x's here. Because your calculator, it's a placeholder. On your paper, it should say y and dy, but on your calculator, when you run the program, you can use x's. That is arc length. So you need to remember the formula that arc length is the integral from a to b of the square root of 1 plus, you can write it this way, the derivative squared dx, unless of course you're going with respect to the y-axis. Most of the time we do dx. And then you need to be able to use your calculator. The homework is on a worksheet, and you should see the attachment on Haiku.